So in this video we're going to look at relative permittivity and the dielectric constant. So in this video we're going to attempt to quantify some of the stuff we were talking about previously. So we're going to consider a capacitor with a fixed potential difference across it, both with and without a dielectric. So here we have without a dielectric, so we just got empty space between our plates, and here we've got with a dielectric, and we see we've got that negative and positive charge over the surfaces of the plate, which we're just going to attract more charge onto these plates as we were talking about in our previous video. So we consider the amount of charge stored by this capacitor with or without a dielectric constant, a dielectric material between the plates. We can define its relative permittivity, and this is really what's going to capture how much of a difference having a dielectric makes to the amount of charge you've got. So first things first, we're just going to talk about the charge on our capacitor. We're going to say that this capacitor has a charge of Q stored on it, and this one has a charge of, this one's got a charge of Q0, forgive me, and this one's got a charge of Q on it. So we're going to say the capacitor charge here is Q0, so we've got plus Q0 on this plate, minus Q0 on this plate. This is our one without the dielectric. Here we've got a capacitor charge of Q, so plus Q on this plate and minus Q on that plate. And we're going to expect that Q is bigger than Q0. If you think about it, Q0 is just the charge when you're just using your bog standard capacitor. Q is when you've got your capacitor with a dielectric. I'm going to say the capacitance of this one is going to be C0, and the capacitance of this one is going to be C. And we'll need that in a moment. So we're going to define its relative permittivity as being the ratio of the charge stored with the dielectric to the charge stored without the dielectric. So we can write that as epsilon little r equals Q over Q0. So just labeling that, that's the relative permittivity, charge with and charge without. So what does this tell us? Well, it tells us that the larger this number is, the larger our relative permittivity is, the more charge the capacitor can store for the same potential difference. So we sometimes call it its dielectric constant. So why is that the case? Well, if you think about it, we've got the same potential difference here, but this Q is the charge when we've got our dielectric. So the bigger this Q gets, the bigger this relative permittivity gets. So the bigger the relative permittivity, then the more charge we have stored for the same potential difference. This just tells us how good our dielectric is. So a dielectric with a bigger relative permittivity will mean we'll store more charge compared to one with a smaller relative permittivity. So what this really tells us is we get to store more charge per volt with the dielectric, and this tells us exactly how much. So we can actually rewrite this in a different way in terms of capacitance. So if you think about it, we might not actually be able to measure the charge across our capacitor, but someone might tell us, well, the capacitance with the dielectric is C, and the capacitance without is C0. From that, can you find the relative permittivity? So what do we do? Well, it's actually quite straightforward. We have to remember that we have the charge and the capacitance here, Q0, C0, that's without the dielectric, and with the dielectric is Q and C. You have to remember that the rules still apply. The relation between capacitance and charge hasn't changed, we just got a different charge and capacitance when we use a dielectric. So we can write that out.
Hey guys. To continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.